Bismillahirrahmanirrahim. So today's topic is evolution from 1G to 4G. So in today's lecture, we're going to see how the things got evolved in the area of cellular communication from 1G on towards 4G. We will not go into too much of detail for each of the generation that we will talk about, but sort of brief overview will be given to you regarding how things evolved from 1G till 4G. So we'll not talk about 5G and beyond in the present lecture, as 5G was a significantly different from the techniques that were there in 4G and all the techniques that were there in 3G, 2G, and 1G. So that is why in today's topic, we will be covering things that are related to 1G, 2G, 3G, and 4G, and how actually things got evolved. So we will not go into too much of detail with regards to each of the generation, but it will provide you an overview of how things got evolved. So, transmitting and receiving voice and data using electromagnetic waves in the air over a fixed frequency band, that is a channel, and each channel has a bandwidth and a capacity, and channels are used by multiple users at the same time, and that is known as multiple access. So there's sort of a quick recap of things that will come in a little while. So regarding the types of wireless communication, we know that the first and foremost is the mobile or the cellular communication that includes GSM, CDMA, 2.5G, 3G, 3.5G, 4G. With regards to portable types of wireless communication, we have IEEE 802.11b, that is a Wi-Fi, 802.11.15 Bluetooth, and then we also have wireless broadbands that include WiMAX and mobile WiMAX. And obviously, these are the types that are mostly related to technologies till year 2011. And few of the slides will cover data that includes some data from year till year 2014. So as I said, that we will not be covering the latest technologies or the 5G and beyond, as this topic basically covers the content that is basically related from 1G till the evolution of the 4G. So with regards to the application of cellular mobile wireless systems, the typical applications, as you all know, there is the first and foremost is the voice, and then there is data, and then real and non-real time video. And the application requirement basically is data rate, the latency, and the bit error rate. So with regards to the data rate, as all of you know, that the speed at which the data is transmitted over a communication channel, that is typically measured in bits per second. So that is the data rate. Obviously, what we want is a good data rate. Obviously, that means more number of bits per second should be transmitted. So that is a data rate. The second thing is the latency. The time taken for a packet of data to travel from its source to its destination, and that is often referred to as delay, right? So what we want is that the time taken for a packet to travel from its source to destination should be as low or as minimum as possible, right? So a good latency requirement is that the time should be as less as possible. And then we have bit error rate, that is the proportion of the bits that have errors relative to the total number of bits that are transmitted in a digital communication. As you know that in digital communication system, the bits are transmitted and received accordingly and processed on the receiver side. So what we want is that the bits should have as low error as possible, and the bit error rate corresponds to the number of bits that are in error divided by the total number of bits that were transmitted. So these are the three requirements in any application, that it should have a good data rate or a high data rate, a low latency, and a very low bit error rate. So these are the three application requirements for any kind of application that is in the wireless communication. Okay, talking about some data that is related to or the stats that are related to the packet data and the voice data. As you know that the voice data means the sort of call that that is usually performed between two people. This comes under the category of voice. But when we talk about the packet data, we are usually talking about the access of the internet, right? So packet data usually involves the access of the internet, right? So basically, it was the year 2007, right? That basically is most important in that sense, because the years before that, it was usually the voice data you can see over here. It was the voice traffic that was carrying most of the network load. But it was around year 2007, that is the month of May, that it was actually the packet data that took over or took the lead from the voice kind of information. And you can see that it got evolved and got significantly higher as compared to voice. So these are the stats for the data traffic growth in WCDMA networks worldwide. So this is more of a trend that is applicable to other kind of networks during that era as well, because WCDMA was sort of a dominant technology during the year 2007, 8, and 9, right? So you can see that the packet data took over from the voice data, and hence packet data was significantly carrying more proportion of the network load as compared to the voice data. And you can see that obviously this data is still the year 2009. So, but this is a sort of a trend that packet data these days is significantly higher than the voice data. Okay, so this is basically the chart that is showing us the number of subscribers that is in billions. So keep this thing in mind. The number of subscribers in billions on the y-axis, and on the x-axis we have the worldwide broadband growth from year 2007 till year 2019. And the source of this is LTE, an introduction from Ericsson, right? So as you can see that there is data regarding the mobile broadband and also from the fixed broadband. So just look at the graph that is showing us the data of the year 2007. So we can see that it's around more than 80% of the total number of subscribers were that of the fixed broadband, right? So fixed broadband was sort of more dominant as compared to the mobile broadband. And there are a number of reasons, obviously, regarding that. One of that is obviously the cost of the mobile broadband internet during that time. So you can see that as we moved along year 2008, 9, 10. So it was around year 2010 that the fixed broadband and the mobile broadband internet, they were almost carrying the same share of load in terms of the number of subscribers, that is in billions, right? So it was in year 2010 that around 0.5 billion customers on number of subscribers were there for the fixed broadband, and around 0.5 billion subscribers of the mobile broadband. But it was year 2011 actually that mobile broadband actually took over from the fixed broadband. Again, as I said, that there are a number of reasons related to that. And as you can see that as we moved along, for example, at year 2014, obviously mobile broadband was significantly more in terms of the number of subscribers. So you can also see that by your own self. You can take your own example. For example, just look at yourself like 10 years before or like 15 years before. So, but these days, the mobile that is in your hands, it is doing almost everything. And that is thanks to the mobile broadband internet that is available at the palm of your hand. Okay. So mobile broadband basically is a high-speed internet access that is delivered over a mobile phone network, right? And that's includes CDMA, GSM, 3G, 3.5G, 4G LTE. Obviously, people in this part of the world mostly are using 4G LTE. And fixed wireless deliver broadband from the backbone of the internet by using base stations to transfer the signal from building to building like a satellite. So this is the example of the mobile broadband. And I'm pretty much sure that most of you right now that are looking at or taking this lecture online is courtesy of the mobile broadband internet. But Broadband internet service in general is the most used form of the internet access because of its high speed. It is offered in four different forms. One is at the DSL, that is a digital subscriber line, fiber optic, cable, and satellite. The old dial-up connection is the only non-broadband internet service available, and even though it is cheaper, most internet users are moving towards a faster broadband internet connection. Obviously, in this part of the world, it was like you can say that more than a decade, it was quite famous that dial-up internet, right? But these days, obviously, mobile broadband and the fixed broadband is more popular, right? But the dial-up internet connection, maybe in few countries, it is still the dominant one, but not at least in this part of the world. Okay, so in this slide, you can see some telco challenges. So it is a very interesting slide over here, taken from the Telecom Italia, that is the Italian National Statistics Institute. And this data is again basically related to year 2008, right? So a few slides before I told you that it was around year 2007-8 that in which the packet data that significantly took over the voice and then evolved exponentially. Okay, you can see that from year 1995 till year 2008, right? So this red line basically corresponds to the telecommunication, right? And we are looking at the price index, right? So if you see the price index, most of the prices of the most of the things are, getting increased with time, right? So since this is an old data, if you look at the data, especially in the most recent years, globally, talking about globally, so most of the things have got sky high in terms of the number of the prices, right? But same as the case was in the decade from 1995 till around 2008, right? The things got increase the price of most of the things. That includes clothes, foods, transportation, restaurants, and things like that. That includes health as well. But if you look at the graph of the telecommunication, so that was basically, the last leg of this 20th century. And then beyond that, you can see that the prices of telecommunication all actually got lower. So this thing is significantly different from all other entities or the commodities if you talk about. So basically, telecommunication got cheaper with time. The other things got expensive with time, whereas the telecommunication got cheaper with time. And this the figure on the right is actually very interesting, right? So you can see on the x-axis we have time. With the time, the traffic is voice dominant, right? Right? From this till this point. But after that, the traffic, as you know that from year 2007 and 8, the data traffic got significantly higher and more number of subscribers got subscribed to the data. So the traffic also got significantly higher. So this is not a linear increase, rather this is an exponential increase. So talking about the revenue, the traffic and the revenue were sort of aligned to each other, right? But as the data got dominant compared to the voice, right? The revenues and the difference between the traffic got a significant difference. So the operator revenue and the traffic got decoupled. So what was the reason? Obviously, as the traffic got increased, so obviously there is more competition between different internet providers, and also things got cheaper in terms of the hardware, right? So as more number of subscribers got there, as the traffic got evolved, obviously the revenue also was increasing, but not in the same proportion, right? So this is sort of a decoupling. It's a sort of a decoupling effect because the data got dominant, right? So mostly the flat rates were there and the revenue and the traffic was decoupled. And this was a trend that that was there in the whole world, not just in some for example, this data is for the Italy, right? So this trend is sort of a global trend that the traffic and the revenues got decoupled with each other. Okay, so key signals from the market. The non-internet IP traffic growth, and let me again tell you that this data is again taken from the Telecom Italia, right? And the source is Cisco 2008, and this graph is showing the petabytes per month, and on the x-axis we have the year from year 2008 till 2013, and it is enlisting different geographical areas of the world like North America, Asia Pacific, Middle East, Europe, Western Europe, and so on. Okay, so the non-internet IP traffic growth around year 2012, it's around 57%, right? And the mobile data traffic growth was around 116%. That is significantly high, right? And the consumers are around 32,467 in the year 2012. That is a rise of the 49%, 49% rise, right? Okay. Again, this slide is taken from the Telecom Italia, and we have technology on the y-axis, and again, years on the x-axis from year 2009 till year 2014, right? So we can see that around year 2009, we have HSDPA, H plus, GPON, VDSL2, and the things are getting evolved. You can see that the data services based on 2G, 3G, LTE card service continuity is there in around year 2010 and 11, and NG-PON 1 at 10 gigabit per second. And then during year 2012 and 14, we have handsets based on 2G, 3G, and then also the LTE. And NG PON 2 got evolved during that period, and around year 2014, the core network also got evolved, and the handsets also got evolved with that. But we are not going into the too much of detail that is mentioned in this slide. Rather, I'm going to cover a few particular things in that in this thing, because few of the things will come later on, right? For example, from year 2009 and beyond, we are already looking at 3G and beyond, right? So I'm not going into the too much of details that is mentioned in each of these boxes. Rather, I will cover few of the things. For example, in this, we'll talk about 3GPP, right? So what is 3GPP? This is basically the third generation partnership project. It's a very important thing. It's a collaborative project that was aimed at developing globally accepted specifications for the 3G mobile system. And the 3GPP caters to a large majority of telecommunication networks in the world. So that was sort of a global project. And we'll also talk about 3GPP in a little while again. But 3GPP, having a know-how of this is very important, because that was a project that has still in year 2023, it has a lot of importance, because things got evolved courtesy of this project. Even in 5G, the role of 3GPP is there, right? So I wanted to mention this 3GPP over here. Okay, another thing that is mentioned over here, and I'll talk about that, is NG PON2. This is also known as TWTM PON. That is the next generation passive optical network, right? So PON corresponds to the passive optical network. And this is basically a 2015 telecommunication network standard. But you can see that NG-PON1 is mentioned over here. That was around year 2011. But starting from year 2014, the next generation of passive optical network got evolved. And that was a standard that was developed by ITU and details an architecture capable of total network throughput of 40 gigabit per second, corresponding to up to 10 gigabit per second symmetric upstream, downstream speeds available at each subscriber. So what is ITU? I'll try to talk about that now. Right over here. So ITU basically is International Telecommunication Union, right? That is originally the International Telegraph Union. This is basically a specialized agency of the United States that is responsible for issues that concern information and communication technologies. And it is the oldest global international organization. So uh, most of the countries that are under the United Nations is a part of ITU. So basically, ITU is that standardizing agency uh, that looks after most of the things that are related to the telecommunications and the related fields. So ITU coordinates the shared global use of the radio spectrum. It promotes international cooperation in assigning satellite orbits. For example, if you for example, just taking an example, if you make some kind of a satellite, it's not possible for you to, make a company and just then work independently on that. Obviously, you have to follow the set of rules, regulations, the technical standards, the technical specifications that are set by the International Telecommunication Union, right? Because your country comes under that, right? So you have to fulfill the laws or the rules and regulations that are set by this organization. It also assists in the development and coordination of the worldwide technical standards. The ITU is also active in the areas of broadband internet, uh, latest generation of wireless technologies, aeronautical and maritime navigation, radio astronomy, satellite-based meteorology, convergence and fixed mobile internet access, voice, TV, broadcasting, and next generation networks. So let me also tell you that as far as Pakistan is concerned, Pakistan has a national preparatory group for ITU and related forums. So I am also one member of that, right? So I'm member of a national preparatory group of Pakistan that is related to the International Telecommunication Union. Okay. One more thing is the UMTS. The Universal Mobile Telecommunication System is a third generation mobile cellular system for networks based on the GSM standard. It was also developed and maintained by the 3GPP that I just talked about. UMTS is a component of ITU, IMT 2000 standard set and compares with the CDMA 2000 standard set for networks based on competing CDMA1 technology. So this is sort of a system that was under this 3GPP project, and that was related to, around, since we're talking about 3G system in this slide. So that was basically, you can say that the evolution of actually the 3G, right, in this slide. Okay, talking about the GSM network architecture, we have already covered this topic before. The GSM network architecture is sort of a revision of that, because few things related to this will come in a little while. So sort of a revision. So as you know that in the GSM network architecture, we have a mobile station and it has a interface with the BTS, and BTS or the number of BTSs have an A-based interface with the PSC, that is the base station controller, and a number of BSCs have connection with MSC, right? That is the mobile switching center. And the MSC is connected to the internet. For example, we're talking about the internet over here. So obviously your mobile, all kind of communication that is related to the internet is going via this path. The data is going from your mobile station to the BTS, from the BTS to the BSC, from the BSC to the MSC, and then MSC is connected to the internet. And with regards to PSTN, ISDN, we already have covered these topics, and we know that It is basically the MSC that eventually is connected to that's the system that is out of the network of any mobile network that you're using, right? Okay, so talking about the mobile station and the BTS and the BSE, for example, this BTS and the BSE, together it makes a BSS, right? So BSS is base station subsystem. So usually we talk about, when we say the BSS, it means we're talking about the BTS and the BSE together. We're talking about the BTS and the BSE together. So that's basically your mobile station, the UM interface with the BTS and till the BSE. This complete network basically is called RAN. That is the radio access network, right? So that was the reason I included this slide over here, because I wanted to talk about RAN, because this MSC and BTS and the BSC together is known as the radio access network. And with regards to the MSCs, the VLRs, the gateway MSCs, and the home location register, the visitor location register, and the subsidiaries that are connected to the MSC, that is basically known as the core network, right? So there is one RAN network, the radio access network, and then we have a core network, right? That includes the MSC and uh, the related set of blocks that you're looking over here. This is basically the core network, right? We know that GMSC is the Gateway Mobile Switching Center. Okay, then we also have NSS. We have also talked about NSS before. That is the Network Switching Subcenter. Okay. Okay. So let us see the fast track evolution from 2G to 4G, and that is sort of a summary of that. And then we'll talk about the gradual influence from 1G to 4G. But quickly looking at from the evolution from 2G to 4G, this fast track evolution. In 2G systems, we used to have TDMA, the time deviant multiple access, right? So during the initial period of the 1990s, we used to have GSM that had a downlink and an uplink of around 9.6 kilobits per second. And the GSM got evolved and included GPRS. We'll shortly talk about this, that GPRS basically is the 2.5G, right? So 2.5G is basically the inclusion of the GPRS. And by that, the downlink speed got increased from 9.6 kbps till from 32 to 40 kilobits per second, and the uplink of around 8 to 14 kilobit per second. And after the inclusion of the GPRS, as I said, that was 2.5G, we got to 2.75G. That includes the edge, right? We'll talk about that in a little while. And again, the downlink and the uplink speed got increased in that. And after that, we got to the WCDMA network. So I've talked about UMTS a little while ago. So that UMTS basically is basically related to the 3G systems, right? And from UMTS, we got to HSTPA and HSUPA and HSP. I'm not sure if most of you have seen that whenever you guys go to a place where you're not getting a good coverage of the 4G, usually you see H written on your mobile phone or H plus written on your mobile phone. So basically in those areas, you're not getting the coverage of the 4G, LTE rather, you're getting these technologies that are under the umbrella of the wideband code deviant multiple access. And as far as 4G is concerned, the technology related to that is LTE, a long-term evolution, and then we have LTE advanced starting from year 2015. That basically has the multiple access systems of OFDM, that is the orthogonal frequency deviant multiple access, right? So this was sort of a summary of a fast track evolution from 2G to 4G. And now I'll gradually now talk about how things got evolved from 1G till 4G. So that was sort of a quick overview of things that were related to 2G, 3G, and 4G. But we're going to look at things from how things got evolved from 1G to 4G, starting from this slide. Okay, Ji. So in the 1G networks, they were basically launched in the mid 1980s, and these were analog systems, and they mostly used the frequency modulation. And as far as the multiple access technique is concerned, the frequency deviant multiple access was used, and it used to carry only the voice traffic. So there was no data involved in that. There was only voice traffic, and hence no internet was carried by the 1G system. Moreover, there was no roaming facility. It was confined to national boundaries only. For example, if you are a resident of some country, you can use your system only within that country, right? The 2G systems were digital in nature, right? In contrast to the analog system that was in 1G. So in 2G systems, they were digital. Moreover, the TDMA FDD was used for the multiple access, and it used to provide the data rates of around 9.6 kbps. The data services actually were in the 2G networks were served by the GPRS. So GPRS was basically the General Packet Radio Service. So I'm pretty much sure that a few of you must be knowing about this GPRS. There used to be a GSM system, and then it got evolved with the GPRS, the General Packet Radio Service. GPRS is an overlay network and allows only low data rate traffic. The TDMA was used as a multiple access technique in that. It's a best effort service suitable for non-real-time traffic. So if you're intended to use some real-time internet traffic, in that case, the GPRS was not very good. Obviously, there was a compromise during that time because due to the lack of the evolution in the technology. In contrast to circuit switch networks, the volume of the traffic was now more important than the time of connection. Okay, so in GPRS, that is the 2.5G. So let me just give a quick overview that the first system or the 2G system was digital in nature, but it did not have that internet facility in that. So it got evolved with the inclusion of the general packet radio service, and that was named as a 2.5G, right? So in the GPRS based GSM system, the GPRS core looked something like this, right? So this is the core of the GPRS system. It included this GGSN that you're looking over here, and that is the first thing that was connected to the internet, right? So the gateway GPRS node is the main component of the GPRS network, right? The GGSN is responsible for internetworking between GPRS network and an external packet switch network, that is the internet, right? Okay. Moreover, there was SGSN that you're looking over here. This was the serving GPRS support node, the serving GPRS support node, and from that it makes SGSN. And it's the main component of the GPRS network which handles all packet switch data within this network, right? So that was SGSN. And then we have the PCU, that is the packet control unit. It is a hardware router that is added to the PSC. It differentiates data destined for the standard GSM network, that was the circuit switch data, or the data destined for the GPRS network or the packet switch network. So there you can say there is a sort of a controller that used to control whether it was a standard GSM network or the GPRS based system, or you can say a sort of a controller that used to control whether the traffic is being routed to the 2G system or the 2.5G system. So basically, the PCU was responsible for that. After that, we have RNC, that is the radio network controller. It undertakes the radio resource management and some of the mobility management functions, although not all. It is also the point at which the data encryption decryption is performed to protect the user data from eavesdropping. For example, you can say that the protection from external threats, you can say, with regards to the interference, basically, this is also controlled by the RNC, right? So this is a sort of the advancements or the extra nodes compared to the standard GSM network. It was GGSN, SGSN. RNC, and the PCU, right? And that it made the GPRS-based GSM system, or the 2.5G. The RAN remained the same actually, and the user equipment required a little bit of hardware upgrade. Obviously, the user equipment should have the capability to manage the GPRS system. The PTS required only the software update. So there was not much of a change with regards to the BTS as far as the hardware is concerned in the GPRS-based GSM network. The BSC required a software upgrade as well as another hardware block that was a PCU. So you can say that as far as this BSC is concerned, so although there was upgrade in the software, but also the PCU was connected to the BSC. The core network was changed, right? So the RAN network remained the same, but the core network, as you can see that it got changed. For voice traffic, the core remained the same. So if there is no data involved, then the core network was the same as the core network of the standard GSM system. As I just talked about, the SGSN and GGSN were added to the core to handle the data services. The SESN, the serving GPRS support node, has an interface with the PCU at the PSC over here. And the GGSN acts as a gateway to the external networks, right? So GGSN, for example, you want to convert to the external network. So if you want to connect to that, obviously, the GGSN is responsible for that. All the databases that include the HLR, VLR involved in the network required software updates to handle the new call model and functions introduced by the GPRS. So that is how the things got evolved from the 2G GSM system to the 2.5 GSM system. And 2.5 obviously is the GPRS-based GSM system. After that, there was Edge, and Edge was basically 2.75G cellular system. Edge basically stands for the enhanced data rate for the GSM evolution. Enhanced data rate for the GSM evolution. It was also known as the enhanced GPRS, and that was a high-speed mobile data standard. The operators can handle 3 times more subscribers than GPRS and triple their data rate per subscriber. So obviously, that was a considerable improvement in terms of the data rate compared to the 2.5G system. Only involve the addition of one extra edge transceiver unit to each cell. So this is very important, that not much of the upgradation in the hardware was required, as it only involved the addition of one extra edge transceiver to each cell, obviously. And obviously, you know that the each cell corresponds to the BTS and the complete system that includes the user equipment. It allows legacy GSM operators to offer their users high-speed data services comparable to those of UMTS. Technology remained the same as GPRS, but uses higher order modulations to increase the data rate. What are the disadvantages of GPRS and Edge? As TDM, or the time deviant multiplexing, is used in both GPRS and Edge, the statistical multiplexing is not possible, right? So the probabilistic model, in order to gain the advantages, that was not possible in the standard TDMA-based system. So there was also wastage of bandwidth that results if low density traffic is sent by the user, because the extra bandwidth that gets useless in that case. Therefore, in these 3G networks, ATM, or the asynchronous transfer mode barrier, is used in order to allow statistical multiplexing. So we're going to talk about that shortly. Just a quick review of the TDMA system. The time deviant multiplexing in telecommunication involved dividing the channel into distinct time slots, with each slot allocated to a different user or the data stream. When using time deviant multiplexing, statistical multiplexing becomes impractical because the channel is rigidly partitioned by time, regardless of whether a user has data to transmit or not. Because the users are, the overall time is distributed to different users, right? So if some certain time slot is, given to a certain user, so regardless of whether he's using the network or not, that sort of time is getting wasted. So this can lead to a bandwidth wastage, especially with the low density or sporadic traffic sort of irregular traffic, as unused time slots still consume the channel capacity. To address this inefficiency in 3G networks, asynchronous transfer mode is employed. The ATM uses statistical multiplexing, allows for more efficient use of the bandwidth by dynamically allocating resources based on the data traffic demand, thereby reducing the wastage, right? So this is the thing that is important, that TDMA was a waste of, not only the resources, but also the bandwidth. And therefore, in 3G systems, the asynchronous transfer mode was used. As far as ATM is concerned, okay, the asynchronous transfer mode is a network technology that organizes digital data into small fixed size cells. This is in contrast to Ethernet and the TCP/IP networks, which use variable packet sizes for data and frames. The key technologies in ATM includes fixed size cells. Just a second. The ATM uses small fixed size cells of 53 bytes. This uniform size allows for predictable and efficient handling, especially suitable for real-time voice and video traffic. And again, ATM was used in 3G, not 2.75G and 2.5G. The ATM establishes virtual circuits for transmitting data, ensuring a predefined path with the quality of service for the duration of the connection. And ATM also provides the quality of service guarantee, which is vital for handling different types of network traffic like voice, video, and data with varying requirements in terms of bandwidth, latency, and packet loss. So let's move on to the 3G. Again, we're going to talk about 3GPP that I already talked about 3GPP before. So just a quick revision of that as it is being talked about here as well. The 3GPP, the third generation partnership project, was an international collaboration between groups of telecommunication standards association. It was established in this December 1998. The purpose of the 3GPP project is to develop and maintain global telecommunication standards, particularly those related to mobile systems such as 3G, that is the UMTS, 4G, that is the LTE, and more recently 5G technologies. It provides a structural framework for creating the technical specification and reports that define these systems, ensuring interoperability and consistency in mobile telecommunication. Uh, with regards to the UMTS, again, quick recap of that. The UMTS is a 3G mobile cellular system for networks based on the GSM standard. Developed and maintained was by the 3GPP project. UMTS was a part of the ITU's IMT 2000 standard. So it may look confusing to you, but that you need to remember that 3GPP was a partnership project, right? The UMTS was the cellular system that was related to the 3G system. And it was a part of the International Telecommunication Union's IMT 2000 standard that was particularly allocated for the 3G wireless technology, right? So over here, we are talking about the 3GPP and release 99, right? So talking about the ITU, they gather on different forums worldwide, and they go through different set of meetings, and they come up with different kinds of ideas, and consensus is developed, and different types of releases are launched into the market, and then that becomes a standard. So 3GPP release 99, the first major release of the UMTS that established the initial global standard for the 3G technology. And that is why the 3GPP release 99, is particularly linked to the 3G technology. It introduced key features such as higher data rates, support for multimedia services, and improved mobile internet access compared to the 2G networks. This release laid the foundation architecture for the UMTS, including the core network and radio access network technology, setting the stage for the evolution of mobile networks into the 3G era. Okay. The core network in the 3G remained the same. The RAN was changed to UTRAN, so UMTS Terrestrial Radio Access Network. So RAN was not no more named as a RAN, rather that was named as a UTRAN, that was the UMTS, and then the Terrestrial Radio Access Network. And TDMA was changed to, the wideband code deviant multiplexing. So instead of the time deviant, we had code that was divided for the multiple access. The BTS and BSE can be reused for existing non-3G users. Few important network elements was added. One was the node B, one was the RNC, and one was the media gateway. The media gateway takes care of all data transferring both circuit and packet switch network. So basically the media gateway was responsible for the data traffic, right? As far as node B is concerned, it is the telecommunications node, in particular mobile communication network, that adhere to the UMTS standard. The node B provides a connection between mobile phones and wider telephone networks. So it was just, you can say better, or at that time, the cutting edge technology with regards to the intermediate nodes in the overall network. So that was used to be named as node B, right? So you can see here that there are node Bs over here. And this is a UTRAN. The UTRAN, the UMTS Terrestrial Radio Access Network, is a radio access network component of the 3G UMTS architecture. It connects mobile devices to the core network and handles all radio-related functionalities. The UTRAN consists of node Bs, that was the base station, right? So just base stations were actually named as node Bs, right? So all base stations that adhere to 3G technology were named as node B. So simply you can state it like that. The node Bs provide the air interface to the mobile devices, while the RNCs manage the radio services and handle tasks like handover decisions, power control, and load control across the base stations. The UTRAN uses wideband CDMA as its primary radio technology, enabling higher data rates and supporting various services like voice data and multimedia in 3G networks. So quick recap of the different multiple access methods. In FDMA, we have the slots corresponding to different frequencies. In time domain, we have slots corresponding to different time. And in CDMA, we can make use of the full time and the full frequency corresponding to each code. So 3GPP release 5 and 6 specified the standards for HD, HSDPA, and HSUPA respectively. This enhancement improved throughput, reduced latency, and increased capacity. HSPA supported peak data rates of 14 Mbps for the downlink and 5.8 Mbps for the uplink. You can see that there's a significant improvement, because we were talking about kbps in 2G systems. So obviously this is megabits per second, significantly higher than the 2G systems. In 2008, we got evolved HSPA, or the HSPA Plus was released. And subsequently that was adopted worldwide in year 2010. HSPA Plus supports peak data rates of 42 Mbps for the downlink and 22 Mbps for the uplink by combining quadrature amplitude multiplexing, 64 QAM, and multiple input, multiple output system. HSDPA is high-speed downlink packet access, HSUPA is high-speed uplink packet access, and HSPA is high-speed packet access. A quick overview with regards to these. The HSDPA, the high-speed downlink packet access, and HSUPA, high-speed uplink packet access, are enhancements to the 3G UMTS network, focusing on increasing data transfer speed. So actually the task was to increase the data speed to as much as possible. With regards to HSDP8, it improved the downlink speed significantly, allowing for faster data downloads, improved web browsing, and streaming media. It is also sometimes called as 3.5G. So instead of HSDPA, you can also say that HSDPA is actually 3.5G, and it had a significantly higher data rate compared to the original UMTS standard. HSUPA enhanced the uplink speed, enabling faster upload of data, which is particularly useful for activities like sending emails with large attachments, video conferencing, and live video broadcasting. So this is how the things got evolved in 3G. Now coming to the 4G, and 4G is the long-term evolution. The number of mobile broadband subscribers, few thousand in late 2006 to nearly 100 million in early 2009, right? So UTRAN was basically replaced by the evolved UTRAN. The WCDMA was replaced by the OFDMA. So you need to remember this. In 4G, the multiple access technique is orthogonal frequency deviant multiple access. In 3G, it was code deviant multiple access. In 2G, it was TDMA system, and in 1G, it was frequency deviant multiplexing. So in 4G, the WCDMA was replaced by OFDM in the downlink and SCFDMA in the uplink. I'll talk about that in a little while. The functionality of the base station or the node Bs and RNC was merged into a single node, and it is now called as E node B, right? So this is E node B, and it combined functionality of node B and RNCs. The IP bearer was introduced, the core network was changed to the evolved packet core. The EPC consists of mobile management entity, PDN gateway, and SAE gateway. E node B is connected to MME through S1 interface, and PDN gateway is connected to external networks, right? LTE, incorporates several key technical components and innovations to achieve high performance. As I said, that it uses OFDM as the multiplexing technique. LTE uses OFDM for the downlink from the base station to the device, right? It divides the broadband signal into multiple narrowband channels at different frequencies, which increases efficiency and reduces interference. So you can say that OFDM basically was sort of an offshoot of FDM, frequency deviant multiplex. But here we divide the broadband into multiple narrow channels that are at different frequencies, right? Incorporating MIMO, that is the multiple input and multiple output technology that involves using multiple antennas at both transmitter and receiver, right? So instead of one antenna at transmitter and one antenna and the receiver, it had multiple transmit antennas and multiple receive antennas. This enhances data speeds and link reliability by exploiting multiple paths that a radio wave can take. The SCFDMA that we talked about is that is being used for the uplink from the device to the base station. It's similar to FDM, but with a low peak to average power ratio, which is more power efficient for the device, right? So your device is not capable enough to handle a large power. So usually in traditional OFDM systems, we have to use large power, right? So that was the reason SCFDMA was used. That has significantly lower peak to average ratio. As far as the modulation technique is concerned, the quadrature phase shift keying, that is the QPSK, 16 QAM, that is the 16-bit quadrature amplitude multiplexing, 64 QAM. LTE uses different modulation schemes depending upon the signal quality. This scheme enables more bits to be transmitted per hertz of bandwidth, increasing the overall data rate. Carrier aggregation is also there in the LTE. It allows LTE to use multiple frequency bands simultaneously, increasing peak data rates and improving overall network performance and throughput. Moreover, there is HARC, hybrid automatic repeat request, that combines error correction and error detection technique, which helps in improving the reliability of the data transmission. These technologies together enable LTE to provide higher data rate, efficient use of spectrum, and in overall better experience with terms of use. For example, I feel very uncomfortable, for example, if I go somewhere and if I'm not getting 4G, because difference between the 4G LTE and 3G seems to be, significantly higher or sort of irritating, right? Few more things related to the SCFDMA, that is a single carrier frequency deviant multiple access. It is particularly used in the uplink, as we just said. It is similar to OFDM, but as I said, that the difference is one is the lower peak to average power ratio, and the other one is it uses single carrier transmission with frequency deviant multiplexers. So there is a single carrier, but deviant in the frequency with regards to that frequency. Okay. Uh, Uh, the PDN is mentioned over here. The PDN gateway provides connectivity from the user equipment to external packet data by being the point of exit and entry of traffic for the user equipment. This is another thing that is, got evolved from 3G. So PDN is not there in the 3G system, right? So that is sort of the gateway. The SAE is the evolution of the GPRS core networks. So that was named as SEA gateway. Uh, with regards to few of the other things that LTE has to offer is higher data transmission with the potential speeds of up to 100 Mbps for the downlink and 50 Mbps for the uplink, which is I think is quite high or a significant jump compared to the 3G systems, in which we were talking about, around less than 10 Mbps in most of the cases, right? A reduced latency, it offers substantially lower latency compared to 3G networks, resulting in quicker response. Obviously, a reduction in latency is something that is very desirable because we want the system to respond as quickly as possible. And for that, obviously, it means the low latency. Improved capacity and efficiency. LTE optimizes the use of the spectrum, allowing more simultaneous users in a single cell and improving network efficiency and capacity. Better support for multimedia services, enhanced speed, and reduced uh, latency facilitates high quality and video streaming. Obviously, uh, when you are talking to someone using WhatsApp and you're using video call, it's pretty comfortable if there is no issue in your coverage. I think it's pretty comfortable. Moreover, there's a wider coverage. It is designed to work over a range of frequency bands, enable widening coverage in rural and remote areas as well. So you can say that 4G is a significant leap in the mobile technology, having a much faster speed, much lower latency, and the efficient use of the network is a much better user experience. So this is it for the evolution from 1G to 4G. So we'll talk about how things got better in 5G and beyond in some other lecture. But today's lecture was dedicated to how things got evolved from initial 1G to 4G system view with few of the stats or specifications that were there. So we'll end this topic of evolution from 1G to 4G over here. Thank you.